primary.
Yes.
So you know primary cation formed in primary amine, that is most basic according to hydrogen bonding. If we compare on the basis of hydrogen bonding, primary amine should be more basic, then secondary, then tertiary. So see, on the basis of hydrogen bonding, order is primary, secondary, tertiary. And if we compare on the basis of plus I effect, order is tertiary, secondary, primary. Okay. Got it?
Understood.
Okay, so now first we talk about methylamines. And then about ethylamines. So if we compare primary, secondary and tertiary amines, see, hydrogen bonding give preference to primary amine and least preference to tertiary amine for basic character, and plus I effect give more priority to tertiary amine than primary amine, and that's why secondary amine took advantage. So in both the cases, secondary amine is most basic because it is midway. Therefore secondary amine is always more basic than other amines. These are special cases, okay? So keep in mind these two cases. They are very much given in NCERT. So now if we have methylamine, you know, if we compare ethyl and methylamine, which one has higher plus I effect?
Ethyl, sir.
Yes, ethyl. So here, while deciding primary and tertiary, plus I effect is dominating. And if we see methylamines, you know, methylamine is smaller in size than ethyl, and that's why in this case hydrogen bonding is dominating, because if hindrance is less, size is small, then hydrogen bonding is more. So in methylamines, hydrogen bonding will decide. So after secondary amine, we have primary methyl and then tertiary. This is the order. But in case of ethylamines, you know, plus I is dominating, so plus I favors tertiary.
Yes.
And therefore tertiary is more basic than primary. So this is the order, and these two are very, very important from the examination point of view.
Understood.
You may get one question from here. So let us do this question. Arrange the following in the decreasing order of basic strength in aqueous solution. So what is the order? Tell me.
Okay, sir. Last.
Hmm?
Decreasing, so adenine will be last.
Okay.
Option A is eliminated, sir. And then ammonia will be second last, which is in all of the options. Then after that we will have aqueous solutions. Okay, the order will be B, then A, C, C, A, B, D, C, A. Option B, sir.
Okay, see. Good. You know, first of all, we have these three. These are aliphatic amines, means alkyl amines, and
Yes.
this is aromatic amine.
Yes.
So obviously we have, see the order, aliphatic amines are more basic than ammonia, and aromatic amine is less basic than ammonia. That means A, B, C should be more basic than D, and which in turn more basic than E. This is the order. Now these are the methylamines. So I just told you that ethyl secondary amine is always more basic. So secondary amine is C. So C should be more basic, and as these are methylamines, so which factor is dominating? Hydrogen bonding, and that's why primary amine is more basic than tertiary. So this is the order: C, A, B, D, E. That means B option is correct. Yes, we have done this question in the last session. Which one of the following species attacks the benzene ring in this reaction?
Cl positive, sir.
Yes. So in chlorination, this is chlorination reaction, and they are electrophilic substitution reactions. So here we have Cl positive, electrophile, and which electrophile is used in nitration?
NO2 positive, sir.
So in nitration there is NO2 positive. In sulfonation,
SO3H positive or SO3?
yes, SO3H positive or SO3. And in Friedel-Crafts alkylation,
CH3 positive.
yes, we can say R positive or CH3 positive. And in Friedel-Crafts acylation,
It is the carboxylate ion.
yes, RC double bond O, no, carbonate is RCO positive. Okay, so that's why here B is the right option.
Understood.
Yes. Out of these four, which one has the highest rate of reaction towards nucleophilic substitution? Keep in mind, it is not electrophilic substitution. Nucleophilic substitution.
Just a second.
Okay, B option is right. Okay, good, because highest rate of reaction towards nucleophilic substitution means, now you know, ring has higher ability for electrophilic substitution because ring is electron rich.
Yes.
But if electron density on the ring decreases, that will increase the nucleophilic attack.
Yes.
So here, if we compare, all are chlorobenzenes,
Yes.
but in second case and third case, there are electron withdrawing groups. Here, it is electron withdrawing due to minus I and minus R effect.
Yes.
And here it is electron withdrawing due to minus I effect only.
Yes.
Here it is electron releasing due to plus I and hyperconjugation.
Yes.
So if we compare them, you know, it has strong electron withdrawing effect.
Yes.
So more is the electron withdrawing effect, greater is the reactivity towards nucleophilic substitution. So see, this NO2 group, it has minus R and minus I because it is at ortho position, and
Yes.
this one is at meta position,
Yes.
and therefore its effect is somewhat less. So if we compare them, we see the order of reactivity. So towards nucleophilic substitution, so B is most reactive,
Yes.
then it is
C.
C, and then
A.
A, and at the end it is B, because in B there is electron releasing group. So that will increase the reactivity towards electrophilic substitution.
Yes.
Okay, so this is the order of reactivity.
So if in option C it was para instead of meta, then can we decide?
Yes, if it is para, so para has more plus R effect.
No, sir. Then how will we compare it to the ortho isotope?
Then ortho will be more.
Because of more minus A.
Yes, yes. Okay, pKa values of para-nitrobenzoic acid is less than that of para-methoxy. Why? So see, we have para-nitro and para-methoxy. So in methoxy, you know, there are lone pairs, and in nitro there is NO pi bond. So you know, this nitro group has minus R as well as minus I effect. Always keep in mind, whenever atom directly attached to the ring has a pi bond, then that has minus R effect. And as nitrogen is more electronegative than carbon, therefore it has minus I effect. Here in methoxy case, you know, it has, due to the presence of lone pair, it has plus R effect, and oxygen being more electronegative than carbon, it has minus I effect. So plus R effect is dominating.
Yes.
So you know, as NO2 is electron withdrawing group, that's why it is more acidic.
Yes. option B, sir.
Electron releasing group. Methoxy is electron releasing, so decreases the acidic strength. Electron withdrawing group increases the acidic strength. Electron releasing groups decreases the acidic strength. And you know what is pKa?
Because pH itself, sir.
It is minus log of Ka.
Yes.
So stronger acid has higher Ka and lower pK. So pK value of this para-nitrobenzoic acid is less. That means it is more acidic.
Yes.
So NO2 group is, first it is written electron donating group. It's wrong.
Yes.
NO2 group is electron withdrawing group, which decreases the electron density on the ring. Para-nitrobenzoic acid is less acidic. Wrong. It is more acidic. Hyperconjugation is more. There is no hyperconjugation. There is resonance.
Yes.
Okay, so B option is correct. Okay. Next is okay, this is the simplest one. This is the alcohol. So identify the tertiary carbon.
It's alcohol, sir.
No. Oh, alcohol is not there. Okay. Let's say this is OH. So which one is tertiary carbon?
B, sir.
Yes. See this A. This carbon is attached to only one carbon.
Yes.
So it is primary. Even F carbon is attached to primary. It is also one carbon. D is also primary.
Yes.
This one is quaternary
Yes.
because it is attached to 4 carbons, and this one is attached to 3 carbon. That's why it is tertiary. So C option is correct. Yes. Now somewhat difficult. Increasing order of acidity of the given molecules in aqueous media is.
Option C, sir.
Okay, increasing order of acidity of the given molecule. So you know, first one is phenol,
Yes.
second one is acetone, third one is fluoroacetic acid,
Yes.
and D option is alcohol. So you know, carboxylic acid is more acidic. Carboxylic acid is more acidic than phenol.
Yes.
So as third is more acidic than first. You know, in B case, hydrogen is attached to carbon.
Yes.
So as hydrogen is attached to carbon, you know, it is least acidic because
Yes.
sp3 hybridized carbon and hydrogen, the bond is almost non-polar. But in D case, hydrogen is attached to oxygen, and you know, in phenol, you know, when phenoxide ion is formed, it is resonance stabilized,
Yes.
but because in A case and D case, in both cases there are OH group, there is OH group, but in this case we have methoxide, so this is destabilized due to the electron releasing effect,
Yes.
and this one phenoxide ion, it is stabilized due to resonance. And in case of fluorine, carboxylic acid, carboxylate ion is resonance stabilized, phenoxide ion is also resonance stabilized. So why carboxylic acid is more acidic than phenol? Because in carboxylate ion, two structures forms are equivalent. Negative charge is on the oxygen only.
Yes.
When it goes like this, again negative charge is on oxygen. But in case of phenoxide, negative charge move from more electronegative oxygen to less electronegative carbon. That's why phenoxide ion is less resonance stabilized than carboxylate ion.
Understood.
Phenoxide ion is, both are resonance stabilized, but phenoxide ion is less resonance stabilized than carboxylate ion, and that's why carboxylic acid is always more acidic than phenol. So
Understood.
it is then 4 and last one is 2. So it is okay, it is increasing order. So second is least, then 4, 1. Okay.
So there was a similar question in IISER aptitude test. Can I send that right now?
Yes, please.
I'm sending it about that.
Okay. Next is the correct order of stability of the following carbocations is.
Just a second. Option B, sir.
Option
D.
mm, 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 mm. See, you know, fourth one, it is resonance stabilized.
Okay.
In this case, it is tertiary.
Yes.
There are 9 alpha hydrogens.
Yes.
It is stabilized by resonance. In this case, this carbocation, it is secondary and it is stabilized by hyperconjugation because 6 alpha hydrogens are there, as well as resonance.
Okay.
It is stabilized by resonance only. But what about this? It is actually cyclic. This is called bridge head carbon.
Yes.
So whenever there is a positive charge on bridge head carbon, carbocation is planar.
Yes.
So this ring structure cannot expand further, and that's why second is least stable.
Okay.
Whenever positive charge is on bridge head carbon, that structure is least stable. Keep in mind.
Understood.
Okay. So it is second least, then it is fourth.
Option C, sir.
Okay.
No.
Yes, because second, if second is least stable, so there is only one option left.
So
Because
do we prioritize resonance or alpha hydrogens?
resonance is dominating over hyperconjugation.
Yes, sir. So then, then one should be more stable, right?
You are right. There are 6 alpha hydrogens and at the same time resonance, but here there are equivalent structures, because here when resonance takes place, it loses its aromatic character. Okay, here there are equivalent structures just like carboxylic acid, carbonate ion.
Understood.
Okay, so C is the right option. Benzene and benzene, you know, these are like this. So because earlier it was thought that structures are like this. So what is the relation between these two structures? These are called canonical structures.
Yes. Okay.
These are canonical,
Okay. These are canonical.
and these three are known as Viva structures. Canonical structure means resonating structures.
Yes.
So what is the relation between these two?
Structural isomers.
They are structural isomers. They are actually structural isomers because formula is same but structure is different.
Yes.
So that's why they are benzene and benzene. They are related as structural isomers.
Understood.
Yes. Benzyl chloride is reacted with different nucleophiles. Nucleophiles are shown below. You have to arrange them in decreasing order of reactivity. Which nucleophile is stronger than the other?
Benzyl chloride meaning, sir, CH2Cl or benzene, right?
Yes. This is benzyl chloride. Actually, this is benzyl group.
Yes.
So benzyl alcohol, benzyl chloride. This is benzyl group. So benzyl chloride react with nucleophile to give this reaction. So tell me, what is the reactivity order of these nucleophiles?
Yes. Will carbocation be formed, sir, in the reaction?
Hmm?
Will carbocation be formed?
There is no need to form a carbocation. Just see the negative part. The one which has more negative charge, that will attack faster because it is actually primary alkyl halide.
Yes.
So this is partial positive and this one is partial negative. So more the positive charge on the nucleophile, that will attack more. That is stronger nucleophile, I mean to say.
Okay.
So in first case it is HO negative.
Yes, sir, this will be mostly active.
Yes, but CH3 C double bond O negative. So it is resonance stabilized.
Yes, sir.
So negative charge is halved.
Yes.
It has more resonance stabilization, and that's why negative charge decreases. Phenoxide,
Okay, sir, understood, sir.
again it is resonance stabilized,
Yes,
but less than
carboxylate ion.
carboxylate ion, and that's why if we compare these two only, so phenoxide ion is more nucleophilic than acetate ion, right? And if we compare CH3O negative and HO negative, you know CH3 group is electron releasing,
Yes.
and it will not cause more hindrance to oxygen because it is still smaller. If it is tertiary butyl group, then there is a steric hindrance. Okay, so due to plus I effect, it will increase the negative charge and at the same time increase the nucleophilic strength. So methoxide ion, CH3O negative is methoxide. So methoxide ion is more nucleophilic than OH negative, and that's why order is A. Option is right. We considered B because you know sometimes we thought of like there is hindrance,
Yes.
but actually methyl is not very large in size, so it will not cause more hindrance.
Understood, sir. If this was
Okay.
a larger alkyl group, then we would take OH.
Now see, this is benzyl,
Yes.
but if we have this is called benzyl,
That's why benzyl. Yes.
and if all the three are attached to some group, means all the hydrogens are replaced by some other group, that is called benzo. So this is benzyl, benzyl and benzo. Okay, now come to next question. The correct order of basic character for the heterocyclic compounds given below.
Okay, sir. Should it force be yeast, sir?
Mm, mm. Yes. No, 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 no. Wrong.
Okay, just a second, sir.
So see, actually, if we compare them, you know, in case of Pyrrole.
Yes.
Pyrrole, thiophene, there's a furan, thiophene, they are all aromatic because they have 6 pi electrons. This lone pair is in conjugation, means lone pair is a part of pi electron cloud here. Means on the second one, lone pair is not available at all for donation because it is basic. So sorry, for basic character we need lone pair. It should donate lone pair, but its lone pair is a part of a pi electron cloud because lone pair is in conjugation with pi bond, and that's why lone pair is a part of pi electron cloud. So second is least acidic. So there are only two options where second is least acidic. Now come to most acidic. See, this nitrogen is sp3 hybridized. This nitrogen is sp3. This nitrogen is sp2. And this one is also sp2.
Yes.
So obviously, you know, sp3 hybridized carbon will give more electrons
Yes.
because that is being less electronegative, that will donate easily.
Yes.
So that means first and third are more basic than second and fourth. But when we compare second and fourth, you know, second one has no lone pair. Though lone pair is appearing on it, but that lone pair is a part of pi electron cloud because lone pair is in conjugation with pi bond. So whenever, I think we have discussed it, whenever lone pair is in conjugation with pi bond, lone pair is a part of pi electron cloud, and that's why lone pair is not available at all for donation. So that's why second is less acidic than fourth.
Okay, sir, if second donates, then it will become anti-aromatic.
No, it can donate, but its donating power is less because it's a fourth one is okay. You mean to say this one?
Yes.
Yes, it becomes anti-aromatic if we donate a lone pair.
Yes. So it will not work.
Okay, yes. Now in this case, it has intact lone pair. It can donate it, but its donating power is less, being more electronegative than in case of first and third. Now when we compare first and third, both are sp3 hybridized. But in first case, there are more number of carbon atoms which can donate electron to it, more plus I effect. In this case, there are only 2 carbons, so plus I effect is less. So that's why first is more basic than third. So that's why order is, means B option is right. Okay, next. Number of stereoisomers of the given compound.
Okay, just a second.
No.
Okay, 2 raised to 8.
Yes, there are 8 isomers. Reason being, you know, this double bond. This double bond is attached to different, it has double bond. At the same time, each carbon is attached to 2 different atoms or groups.
Yes.
So that's why it is one of the stereo center. Now come to next. It is carbon attached to H, OH. So again carbon attached to hydrogen.
Yes.
So this is chiral carbon.
Yes.
Next again it is again chiral carbon. Sorry, it is again a stereo center.
Yes.
Chiral again stereo center. What about this? Is it a stereo center or not?
No, sir.
Because on one side there are 2
Same group.
same groups. That's why it is not a stereo center. So there are 3 stereo centers
Yes, sir.
and
2 raised to
ends are different. So that's why number of stereo isomers is always equal to 2 raised to power n. N means number of stereo centers. So total there are 8 isomers. So there are 8 isomers. Yes, correct order of the boiling point of these compounds.
ester will be lowest, sir. Sorry, ether will be lowest, sir.
Yes, first we compare alcohol and ether. So alcohol forming hydrogen bond, and that's why alcohols have higher boiling point than ether. Means first is alcohol, third is alcohol, fourth is alcohol. So first, third, fourth is has higher boiling point than second, because in ether there is no hydrogen bonding. Okay, now compare first, third and fourth. So now hydrogen bonding part is over, because first, third and fourth all have hydrogen bonding. So keep in mind, hydrogen bonding is inversely proportional to steric hindrance.
Yes. Or branch.
Yes, and van der Waals attractions. That is directly proportional to surface area and inversely proportional to branching, because as branching increases, surface area decreases, because it becomes more like sphere. So branch here, there is a linear chain. In this case there is one branching, one, two, three, four. There are 4 carbons. Here 1, 2, 3, 4. But here there are only 3 carbons. So we can compare with carbon as well. So fourth has least number of carbons, has less molecular mass. So, fourth is less than first and third. Now in first and third there is branching. In first case it is linear chain, in third there is a branch, and that's why first is more than third, then it is fourth, and then second. So C option is right. So option C.
Understood.
Okay, next. Okay. Which one is the correct statement for the following structures?
Just a second. So what is a constitutional isomer?
Constitution means structural.
Oh,
There is a change in constitution, matlab change in the chain or position and all.
okay. Option B, sir.
1 and 2 are resonance structures.
No, sir. No, sir. Just a second. Option C, sir. One and three will be resonance structures.
How is it? Is it possible?
Yes, sir. If the pi bond in one between N and C shifts to N bond, and this
Say
is
in
also
one, the carbon is attached to one sigma bond, a one hydrogen.
yes.
In third, carbon is attached to two hydrogens.
Oh,
There is a shifting of atoms as well.
okay, yes. Sir, can one and two be resonance structures? Sir, I think one and two can be resonance structures.
There is one carbon nitrogen bond, one nitrogen nitrogen bond. One and two are resonating structures.
And three will be an isomer.
C is an isomer of 1 and 2. So that means B option is right.
Okay.
Okay.
Yes.
So, okay. Arrange the following in increasing order of their boiling points.
D will be maximum.
This is alcohol.
Yes.
So alcohol has higher, more hydrogen bonding than in amines.
Yes.
So D has highest boiling point. Great. And that is in 3 cases. That is quite obvious that D should be higher.
Oh, yes. Sir, then primary amine
Okay, primary amine, and this is primary amine because there are two hydrogens.
Yes.
Secondary amine. Okay, this is tertiary amine.
Yes, sir. So I think option C.
Yes, it should be option C. So because they have same molecular mass,
Yes.
so obviously primary boiling point of in amines, boiling point of primary is greater than secondary, greater than tertiary due to greater hydrogen bonding in primary amine.
Yes.
Okay, so question is, nitrogen containing compounds, they are basic in nature and their basic strength depends on the case of availability of lone pair of electrons on the nitrogen atoms.
Yes.
So for the following nitrogen containing compounds, what will be the correct order of basicity?
Just a second. So lowest will be E and then C. After that, then sir A will be most basic.
Yes. So see, A is secondary amine,
Yes.
and say if we compare A, B, C, D, E, A and D are most basic because nitrogen is sp3 hybridized in both,
Yes, sir.
but this one is primary amine and this one is secondary. So obviously A is more basic than D. Again, if we compare C, C should be least.
Okay.
We have done this question.
Yes, sir.
Lone pair is in conjugation. So C should be least. That means D option is correct.
Yes.
Because if we compare A, D, B, now out of E and C, in E, lone pair is out of the ring, though it is in conjugation. Okay, but here lone pair is intact. In this case, lone pair is in conjugation. So lone pair is less available on nitrogen, but this lone pair is very much available on it because it is not in conjugation at all.
Understood, sir.
So that's why E is less basic than pyridine. This is called pyridine.
Yes.
Okay. What is the correct structure? This is the most simple question.
Yes, sir. Option C.
N dimethyl ethanamine. So when we see ethanamine, parent is ethanamine. So it is CH3, CH2, NH2. Now on the nitrogen, both the hydrogens are replaced by methyl because it is N dimethyl aniline. Sorry, N dimethyl ethanamine. So it should be C. What is the name of A? or IUPAC name is NN-dimethyl methenamine. This one is N-ethyl, and this is butane 1-amine. Arrange this carboxylic acid in increasing order of their acidic strength.
Sir, in A and B we will compare by inductive effect, right, sir? So A will be stronger as well than B.
Hmm.
Then answer D will be stronger as well than C.
Yes.
Answer DC will be stronger acids than no. Wait. So CH phenyl group has plus R effect. Sorry, this carboxylic acid group has plus R effect, right, sir?
Hmm.
No, minus R effect.
Minus, not minus R. Phenyl group has, actually here it is minus I, because benzoic acid will not undergo resonance.
Okay. So we will take in account minus I effect of benzyl group.
It should be option C, because if we compare these, C and D should be more acidic than A and B, because in this case there are phenyl groups, and which has, we take it as minus I group attached to the COH group, and because of this C and D, they are more acidic than aliphatic carboxylic acids, and methyl has less electron releasing effect than ethyl.
Yes.
And if we compare D and C, it is closer, it is directly attached to COH. Here, due to the presence of CH2, its effect is less. So D is more base acidic than C, then it is A, and then B. That's why C is the right option. Okay.
Okay.
Oh my God. Okay, only 3 questions left. Yes. Tell me fast. What is the compound formed?
This will be option B, sir.
Yes, we will use Markov-Nikov's rule. And what is Markov? What?
Why are C and D given?
Actually, C and D are given just to confuse you that is it the formation of a ring structure?
Yes.
So rich becomes richer. That is formula used here, that the one which has more number of hydrogens
Yes.
on the double bonded carbon, that will get hydrogen, or negative part is attached to that carbon which has lesser number of hydrogens.
Understood.
So B is the right option. Yes. What is orthocresol?
Orthocresol is OH and CH3 groups.
This is orthocresol. Then it is phenol.
You have to compare acid and base, right?
Metanitrophenol. Orthonitrophenol. And last one is ethanol. So obviously if we compare phenols and ethanol, you know, phenols are more acidic than
Option D.
so first, okay, if we compare A with B, obviously B is more acidic than A,
Yes, sir.
because you know methyl group has electron releasing effect, plus I and hyperconjugation decreases the acidic strength. But in C and D, nitro group has withdrawing effect, and therefore C and D, they are more acidic than phenol, and phenol is more acidic than orthocresol, which in turn more acidic than ethanol.
Yes.
Now if we compare C and D, you know, NO2 group at ortho is more withdrawing because of both minus I and minus R than at C, and therefore D is more acidic than C.
Understood.
So it is option D. Okay, which one is most acidic?
Option C, sir.
Yes, it is option C. It is very much clear because only in this case there is a electron withdrawing group. Here it is plus I and hyperconjugation. In first case it is aromatic aliphatic alcohol, benzyl alcohol. So if we see the order, C is more acidic than B, B is more acidic than D, and which in turn more acidic than A. So this is the order of acidic strength.
Understood, sir.
Okay, this is the last question. Aryl halides. Well,
On WhatsApp, I have sent a question on acidic strength.
okay, so see this question. Aryl halides do not undergo nucleophilic substitution reactions under ordinary conditions. Why? So these are the reasons. So which reason is correct?
Yes. So one of the options will be A.
Approach of nucleophile is retarded because you know benzene ring is electron rich.
Yes.
So nucleophile attack is retarded. The A option is obviously right. Carbon carrying halogen is sp3 hybridized, wrong, because in aryl halides, you know, chlorine carbon halogen is attached to sp2 hybridized carbon.
Yes, sir. Option A should be correct, sir.
Substrate molecule is destabilized and there is partial double bond character
Yes.
due to resonance. So A and D means A option is correct.
Understood.
So one last question. What is the correct order of acidity in the following case? So see, first of all, you know, carboxylic acid is stronger acid okay, but 2,4,6 trinitro it is more acidic than even than benzoic acid
Yes.
because 3 electron withdrawing groups are attached, and due to these 3 electron withdrawing group it becomes more acidic.
Understood.
That's why P is more acidic than N. Otherwise, carboxylic acid is stronger acid than phenol, that you know. But because of the presence of 3 nitro groups
Yes.
on phenol, it becomes more acidic than benzoic acid even. So that's why P is more acidic than N. Now if we compare phenol and paranitrophenol, you know paranitrophenol is more acidic than phenol. So this
So
is
if we compare dinitrophenol with
yes.
or orthopyrodinitrophenol with carboxylic acid,
Then benzoic acid is stronger.
okay.
If there is 1 nitro or 2 nitro, then benzoic acid is stronger than the dinitro or mononitro benzoic acid is phenol. But if we have trinitrophenol, that is more acidic than even benzoic acid.
Understood.
Okay. So thank you so much. Okay, beta. Good night.
Good night, sir. Please send today's PDF to me, sir.
Okay, okay. I will.
Good night.
Good night. Thank you so much to all of you. जो लास्ट तक बने रहे. It is a great journey today. I hope you have learned so many things and you will apply this knowledge whenever you have any competitive exam. God bless you all. Happy learning, and do share this video with your friends so that they will be benefited. Okay, God bless you all. Bye bye. Yes, good night, Prabhat. Okay, good night, Chehar.